Hello and welcome. In video 16 and video 17, we discussed the ReLU activation function, its advantages, and a major limitation known as the Dying ReLU problem, where neurons become inactive and stop learning during training. We also introduced Leaky ReLU as one of the solutions to this issue. In this video, we dive deeper into Leaky ReLU. Prior to describe Leaky ReLU, let's look at these two figures. Can you tell difference between them? These figures illustrate the key difference between Leaky ReLU and ReLU activation functions. Figure A shows slight negative slope for negative inputs, ensuring small but non-zero gradients, which prevents the Dying ReLU problem. In contrast, the figure B depicts flat line for negative input along the x-axis. This flat line represents zero output and zero gradient for all negative inputs, which can cause neurons to die and stop learning if they get stuck in this region. So, Leaky ReLU can be defined as: it is a modified version of the standard ReLU activation function, but with a small, non-zero slope for negative input. This leak helps keep the neurons active even when receiving negative inputs, thereby mitigating the Dying ReLU issue. Now let's take a look at how Leaky ReLU actually works. It is mathematically represented by this equation. For positive inputs, Leaky ReLU behaves identically to ReLU, passing the input directly. For negative inputs, unlike ReLU, which outputs 0 for negative inputs, Leaky ReLU outputs a small negative value, for example, 0.01 times the input, allowing a small gradient to flow. Alpha is a small constant, typically 0.01, also called negative slope. This small slope allows gradients to flow even when the input is negative, which keeps the neurons alive during backpropagation. So, when should we use Leaky ReLU? Leaky ReLU is often used in deep networks where ReLU struggles to keep all neurons active, especially in layers where a large number of activations may fall into the negative region. Now let's take an example to see how Leaky ReLU works. Suppose our input is -2 and the leak factor alpha is 0.01. ReLU gives 0. This is a flat output. No slope, no gradient, no learning. The gradient for all negative values is 0, which causes the dying neuron problem. Leaky ReLU gives -0.02. This is not flat. There's a small negative slope. The derivative is 0.01, so the neuron still has a gradient and can keep learning. The computation is summarized in this table. As you can see, Leaky ReLU maintains a small but non-zero gradient for negative inputs as well, which helps preserve the learning process. That wraps up today's video. Please don't forget to subscribe our channel, like the video, share, and comment it to stay updated with this series.